So let's just go over the Pythagorean theorem. The Pythagorean theorem applies to right triangles. This is a right triangle that I drew here. A right triangle is a triangle that has a right angle. And a right angle, you remember, is a 90-degree angle. Another factor about triangles, let's say that this angle, so I'm told this angle is 40 degrees, and I want to know what this angle is here. We're going to use this symbol a lot to represent unknown angles. It's the Greek letter theta. So if I ask you, what is theta? You would know, or you should know, that the sum of the angles in a right triangle is 180 degrees. Since this is a right triangle, that right angle is 90 degrees. So I've already got 90 of those 180 degrees taken care of. So I know that the sum of these other two angles must be 90. So 40 plus theta equals 90. And that would mean that my unknown angle is 50 degrees. So that's just a review if you want to know what that angle would be in that case. Also, with right triangles, we have the side opposite the right angle has its own name. It's called the hypotenuse. And this is important. It's important to be able to identify the hypotenuse. It's always the longest side of a right triangle. And it is always opposite the right angle. So that's some basic vocabulary. Now let's get into the Pythagorean theorem. So we're going to talk about the Pythagorean theorem. Let's just review that. You'll remember the Pythagorean theorem is written as a squared plus b squared equals c squared. And the only thing that you really could screw up with this is remembering that c must be the hypotenuse. So it doesn't matter what you call a and b. So c is the hypotenuse if I'm using the Pythagorean theorem. I can call either one of these two legs a or b. It doesn't matter. So here I put a on top and b on the side there. I could just as easily have called this b and this a, and it doesn't change my calculation. But if I get c wrong, I'm going to do this wrong. So make sure you get that right. Now let's get let's go over a real example. So let's take a right triangle and apply the Pythagorean theorem to find an unknown side. So that little box, remember, tells me that that's a right angle. Let's say I know this is 10, I know this is 6, and I want to know what this is, and I'll call it y. I could call it whatever I want. I'm going to recognize that this is a Pythagorean theorem problem, so I know the equation that I'm going to use is that a squared plus b squared equals c squared. Well, what's my unknown here? My unknown is called y. Remember, a and b are just these legs of the triangle. The only thing that matters, the only thing I could mess up is the hypotenuse. So I just have to remember that this hypotenuse, the side that's opposite this 90-degree angle, I have to call c when I use the Pythagorean theorem. And I can call y, my unknown side here, I can call it a, I can call it b. It doesn't matter. Let me get a different color here. I'll call it a just so you can follow along with what I'm doing. So I want to solve for a. I want to know what this is, and I'm going to isolate it. I'm going to get a all by itself. So the first thing I'll do, you do not have to show me these steps. I'm showing them because a lot of students end up with pretty rusty algebra skills. So b squared minus b squared is 0. So I end up with a squared equals c squared minus b squared. Well, I don't want to know what a squared is. I don't know what y squared is. I want to know what y is. So I'm going to take the square root of both sides. The square root of a squared is a. So a is going to equal the square root of c squared minus b squared. I'm going to substitute. C is 10, so it's 10 squared minus 6 squared. 10 squared is 100. 6 squared is 36. So I'm going to end up with the square root of 100 minus 36. I'm calling it y here, so I just switched. 100 minus 36 is 64, and I know the square root of 64 is 8. So I put a circle around it and see the work is I can follow along. I did one step right after another, and you can see where I got this answer. We'll do one more. So here's another right triangle problem, and here you're asked to find theta also, and you're asked to find x. So you have two unknowns. One of them is theta over here, and one of them is x. So I could find theta pretty easily. Let me do that first. I know that all these angles must add up to 180 degrees. I have a right angle, so that's 90. So that means 35 plus theta must equal the other 90 degrees. So I can say that theta is going to be 90 degrees minus 35 degrees, and that is going to equal 55 degrees. So I found theta, put a little circle around it, and now I just want to know what x is. I'm going to use the Pythagorean theorem here. I have 12 and 9. I'm given as two sides of this triangle. I want to know what x is. Remember the Pythagorean theorem, first thing you want to do is go in that 90-degree angle and make sure you know what the hypotenuse is. This is the hypotenuse. It's the side opposite the 90-degree angle. And so in the Pythagorean theorem, just make sure you're going to call that C. For clarity's sake, so you can follow what I'm doing, I'll call 9A, we'll call this B. You could switch those and call the unknown x the letter A and 9B, it doesn't matter. But let's write our Pythagorean theorem. A squared plus B squared equals C squared. I want to solve for B. This is just like last time. It's going to be the square root of C squared minus A squared, and so it's going to be 12 squared minus 9 squared. And when I solve for that, I put it in my calculator, I get 8. I get 7.9, I get 8. And so that's it. That's the Pythagorean theorem. You have lots of practice problems. Go ahead and do them. And when you're ready, move on and make sure you understand the trig also.